Hey guys, we're going to start Chapter 4, Section 1 today, and that's on inequalities and graphing them. So first we want to look at what the solution of an inequality is. And it's just any number that makes the inequality true. So before I go into some examples of that, I want to make sure that we know what each inequality sign means. So if I want to say that something is less than, then I would draw that by using the less than symbol, which is going to look like this. So it's just indicating that our greater value would be over here with our lesser value over on this side. And one way we can think about that is if this were to be like a mouth of like an alligator, they would always want to eat more rather than less. So our greater than sign is going to be the opposite of that, with our greater value here, our lesser value here. Now we can also have a value or a symbol that indicates something is less than or equal to or greater than or equal to. So less than or equal to symbol would be the same as a less than, but then with a line underneath it. So for example, if I had x is less than or equal to 3, that would just mean that x could take on a value that is equal to 3 or any value less than 3. So with inequalities, we see that x can actually have an infinite amount of solutions, as opposed to the solutions and equations we were looking at before. So then just with our greater than or equal to sign, we have the opposite, and then the line underneath. So I'm going to look at some examples below here, and we can see what it means to solve an inequality. So sorry this is a little blurry, but we have here that is asking if each of the numbers below is a solution to 3 plus 2x less than 8. So all this is saying is we want to plug in -2, which is what this value says right here, and see if it is going to be a solution to our inequality. Okay, so we have 3 plus 2 times, and then -2 is our value we're plugging in, is less than 8. So if we want to see that's true, then we follow out with our algebra. We have 3 plus -4 is less than 8. So then we're going to have -1 less than 8. And this is obviously going to be true, since -1 is a smaller value than 8 here. So now we want to look over to our next problem, B, which is the value 3 there. So I write down 3 plus 2 times 3 less than 8. And then with our algebra, we end up getting 3 plus 6 less than 8. And finally, we know 3 plus 6 is 9, so we have 9 less than 8. And obviously here we know that this isn't going to be true because 8 is a smaller value than 9. So if we wanted that to be true, we would have to switch this to a greater than symbol. So what I want you guys to do now is flip over in your packet and look here at these check problems. And maybe try these out on your own. Just pause the video and see what you get, and then we can come back and we can review them together. So we're going to look at, is each of the following numbers a solution to 6x minus 3 greater than 10? So first we're plugging in 1 for x. So we have 6 times 1 is minus 3 greater than 10. So if we go through with our algebra, we know 6 times 1 is just going to be 6. And then we have minus 3 greater than 10. And then finally what we're going to get, I'm going to write it down here, is that 3 is greater than 10. Now obviously this is not going to be true, so we can say that 1 is not a solution to this inequality. Now if we look at 2, we have 6 times 2 minus 3 is greater than 10. Okay, and 6 times 2 is going to be 12. So we have 12 minus 3, which gives us 9. We have 9 greater than 10. And once again, we just see that this isn't going to be true because this is our greater sign, and we have a lesser value on this side. So if we try out with part C here, we have 6 times 3 minus 3 greater than 10. And here we have 6 times 3 is 18. So 18 minus 3 greater than 10. And this is going to end up giving us right here, 15 minus 3, or sorry, just 15 greater than 10. Now obviously this one is true because 15 is a larger value than 10. And then finally over here for part D, we have 6 times 4 minus 3 greater than 10. When we plug this in, we get 24 minus 3 greater than 10, and then finally we'll see that 21 is greater than 10. And once again, this is true just because 21 is a larger value than 10. So hopefully you guys are feeling comfortable with this. So we're going to move on to graphing inequalities. So if we go back in our packet to our first page, and we can go down to the graphing inequalities section. So when we graph an inequality, we're going to graph them on a number line. And you should always draw your number line, appropriate to what the value is you have. So if I were to have a value of, 8, then obviously this number line wouldn't be appropriate for me to use. I would want to shift it over to the right and include values of 8 and greater and less than 8. So first we're going to have a graph of d less than 3. So when I see that a value is just less than or just greater than a number, then I indicate that on the graph by using an open circle at that value. Sorry, this isn't going to be right on, but we'll get the idea. So I have this open circle here on the value 3. And now we know that d is less than 3. So it would indicate that all of these values here, smaller than 3, are going to be solutions. And I want to make this a line with an arrow because it's never ending. So like every number to the left of this 3 is going to be a solution for this. So then we just, over here, we see the solutions of d less than 3 are all points that point to the, and obviously, like I said, to the left. So I'm just going to indicate that by writing in are all the points to the left of 3. Okay, so now we're going to look at the graph for part B, and it says graph -3 greater than or equal to g. So, in this case, since it's greater than or equal to, I show that by drawing a solid circle on the value itself there. So I fill that in, and that just shows that it can be equal to 3. So then, with that, I will draw it's greater than or equal to 3, -3, sorry. So then I will draw my line to the right. And once again, I want to use an arrow just to indicate that it can be any of these values ongoing past this 2 to the right of -3. So when I'm filling this in, this sentence here, it says the solutions of -3 are, and that's going to just be -3 itself, since we have the greater than or equal to, and then all the points to the right of -3. Okay. So now if we look below here, we can even take the graph itself and write an inequality. So here I have this graph with the line pointing to the left from 2 and a filled-in circle at 2. So this just shows that the values of x can be less than 2, and I'm going to draw this in. The values of x are less than 2, and since we have that full circle there, it can be less than or equal to 2. So if I look at this next one here, I have a -3 and a line pointing to the left once again. But the most important part here is that I see that circle is filled in. So that tells me that once again I'm going to use a symbol with a line underneath it. So, and since it's to the left, so it's all the values that are less than 3, they're -3. I want the less than or equal to sign. And I'm going to say x is less than or equal to -3. So if I were to fill in these blanks here, I would just say, the numbers that are less than or equal to 2 are graphed, and here the numbers that are less than or equal to -3 are graphed. So we can practice this on the next page here. And we see, let's see. Okay. The problem's down here. So I want you guys to take this time, and I want you to pause the video once again and just kind of try these problems on your own. If you make mistakes, that's okay, because we're going to come back and I'm going to demonstrate them for you. Okay, so first for part A here, and I'm going to just do a few of these because we're low on time, but for part A here, I'm going to see that we have A is less than 1. So I'm going to put out my values that I want, that I think are going to be, the best to show all the information. And I'll make the 1 here, so then we have 2, 3, 4, whatever. And then this would be our 0. We have -2 and -1. Okay, so this is less than. I'm going to draw an open circle at the 1, just because it's less than and not less than or equal to. So I have this open circle at the 1, and then A is less than 1. So it's going to go to the left for the values that are smaller. Once again, don't forget that arrow just to show that it's an ongoing solution there. Okay. So now I'm going to try out 3A down here. And if you have questions on the other problems, we can talk about that in class. So for 3A, it says write an inequality for the graph given right here. So I see that I have a solid circle at 2. And then my line is pointing to the right. So this is indicating that x can take on the value of 2. So I have x, and then since it's to the right, it's all the values that are going to be greater than 2. So I have x is greater than or equal to 2. And once again, I'm just going to let you guys try out the rest of these problems by yourself, and we can talk about them in class. But hopefully this is a good intro for you, and just make sure that when you come to class tomorrow, you're bringing questions and any confusions, and we can get some more practice in. So I'll see you guys then.